Every day, millions of products move through warehouses around the world. Packages are picked, pallets are transported, and inventory is constantly flowing from suppliers to customers. Most people see the trucks, shelves, and forklifts. What they don't see is the hidden energy system that keeps everything moving. Behind many modern warehouse operations is a hydrogen-powered ecosystem built around Plug Power's GenDrive fuel cell technology. Today, we're going inside that system to uncover how hydrogen becomes productivity. When most people think about warehouse forklifts, they assume they're powered by large batteries. For decades, that was true. Lead-acid batteries dominated the material handling industry. But batteries come with challenges. They require lengthy charging cycles, dedicated charging rooms, battery swapping procedures, and performance often declines as charge levels decrease. Modern distribution centers operate around the clock, and every minute of downtime affects productivity. That's where hydrogen fuel cells enter the picture. Plug Power's GenDrive technology was developed to provide continuous power while eliminating many of the operational limitations associated with the traditional battery systems. What makes GenDrive unique is that it fits directly into the same space previously occupied by the battery. Rather than redesigning the entire forklift, operators can replace the battery with a hydrogen fuel cell power unit. The forklift itself remains largely unchanged. The chassis stays the same. The lifting system remains the same. The drive system remains the same. What changes is the energy source. Instead of storing electricity inside a large battery pack, the vehicle now generates electricity on demand using hydrogen and oxygen. This approach creates an important operational advantage. Battery-powered forklifts often require charging periods that can last several hours. Facilities operating multiple shifts may need battery changing stations and additional battery inventories. With GenDrive, the forklift can be refueled much like a vehicle at a fueling station. Hydrogen is transferred into the onboard storage system, allowing the forklift to return to work in just a few minutes. Rather than waiting for electricity to be stored in a battery, the vehicle simply receives more hydrogen fuel and continues operating. The refueling process is a critical part of the overall hydrogen ecosystem. Inside the warehouse facility, hydrogen is stored, managed, and delivered through dedicated infrastructure. Operators connect the fueling nozzle to the forklift's hydrogen interface and transfer hydrogen into the onboard storage system. Advanced control systems continuously monitor pressure, temperature, and flow rates to ensure safe operation. Unlike battery charging rooms that occupy valuable warehouse space, hydrogen fueling stations can support large fleets while minimizing downtime. The result is more equipment availability and higher utilization rates. But refueling is only the beginning of the story. The real magic happens inside the GenDrive fuel cell itself. Hidden beneath the exterior casing is a sophisticated electrochemical power plant. Hydrogen enters the system through carefully engineered distribution channels. Air from the surrounding environment is drawn into the fuel cell through an intake system. These two inputs, hydrogen and oxygen, are the ingredients required to produce electricity. At the center of the system sits the fuel cell stack. This is where hundreds of individual fuel cells work together to generate usable power. Each cell contains catalyst layers, gas diffusion materials, and a proton exchange membrane. Hydrogen molecules enter the anode side of the cell and encounter a catalyst. At this point, something remarkable happens. The hydrogen molecules split into protons and electrons. The membrane allows the protons to pass through but blocks the electrons. Since electrons cannot cross the membrane directly, they are forced to travel through an external circuit. This movement of electrons creates an electric current. That current becomes usable electricity capable of powering motors, control systems, sensors, and hydraulic equipment. On the opposite side of the cell, oxygen combines with the protons and returning electrons to complete the reaction. This process occurs continuously as long as hydrogen and oxygen are supplied. Unlike a battery which gradually depletes stored energy, the fuel cell continuously generates electricity. That means operators experience consistent power output throughout the shift. Forklift performance remains stable from beginning to end. Acceleration remains consistent. Lifting performance remains consistent. Productivity remains consistent. The electricity generated by the fuel cell flows through power electronics before reaching the forklift systems. Advanced controllers regulate voltage and current while ensuring that energy is delivered efficiently. Electric drive motors convert that electrical energy into motion. Hydraulic systems use electrical power to lift and lower heavy loads. Every movement of the forklift is ultimately powered by the electrochemical reaction occurring inside the fuel cell stack. One of the most interesting aspects of hydrogen fuel cells is what comes out of the system. Traditional combustion engines produce carbon dioxide, nitrogen oxides, particulate matter, and other emissions. Fuel cells operate differently. The primary outputs are electricity, water, and heat. As hydrogen and oxygen combine, water is produced as a direct byproduct. Small amounts of heat are also generated and managed through the cooling system. This means the forklift can operate indoors without producing the exhaust emissions associated with conventional combustion equipment. The water produced by the fuel cell represents one of the most visible symbols of hydrogen technology. Instead of smokestacks or tailpipes emitting pollutants, the reaction creates clean water. This contributes to improved indoor air quality and creates a cleaner operating environment for warehouse personnel. It also aligns with broader sustainability goals pursued by many logistics and distribution companies. However, the forklift itself is only one piece of a much larger puzzle. To fully understand GenDrive, we need to step back and look at the complete hydrogen ecosystem. Hydrogen arrives at the facility through a supply chain that may include production plants, transportation networks, storage facilities, and distribution systems. Once delivered, the hydrogen is stored on-site in dedicated tanks. Compression equipment prepares the hydrogen for dispensing. Refueling stations transfer hydrogen to forklifts. The fuel cells generate electricity. The forklifts perform their work. Data systems monitor performance, safety, and utilization across the entire operation. Refueling stations transfer hydrogen to forklifts. The fuel cells generate electricity. The forklifts perform their work. Data systems monitor performance, safety, and utilization across the entire operation. This interconnected infrastructure transforms hydrogen from a simple fuel into a complete energy ecosystem. Every component has a role. Storage systems ensure availability. Compression systems prepare hydrogen for delivery. Fueling stations minimize downtime. Fuel cells generate power. Monitoring systems optimize operations. Together, these elements create a hidden industrial machine that most people never notice, even though it plays a vital role in modern logistics. What makes GenDrive particularly interesting is that it demonstrates how hydrogen can solve real operational challenges. The technology isn't simply about producing clean energy. It's about improving equipment utilization, reducing downtime, simplifying operations, and supporting large-scale logistics networks. The value proposition extends beyond sustainability and into the economics of warehouse productivity. As distribution centers continue expanding to meet the demands of global commerce, energy systems will become increasingly important. Whether hydrogen ultimately dominates or competes alongside batteries and other technologies, one thing is certain. The future of logistics depends on reliable, efficient energy infrastructure. Plug Power's GenDrive system offers a fascinating example of how hydrogen can move from theory to practical industrial application. The next time you see a package arrive at your door, remember that behind the scenes there may be an entire hydrogen ecosystem helping make that delivery possible. Hidden inside warehouses around the world, hydrogen fuel cells are quietly converting molecules into motion, turning hydrogen into productivity, and powering one of the most important supply chains in modern civilization. If you'd like to explore more hidden hydrogen technologies, fuel cells, electrolyzers, storage systems, and industrial energy infrastructure, visit H2 Hub by Renee Energy, where we break down the engineering realities behind the technologies shaping the future of energy.